I want to go over using Excel for the binomial distribution, and I'm going to do problems 22 through 24 here. And the reason I'm doing all of them is because I want to show you exactly, at least, and fewer than, because they're going to show you the upper end, the bottom end, and a specific value. So we are told that adults with smartphones are randomly selected. 54% of them use them in meetings or classes based on a data from LG smartphone survey. So our probability that someone uses a smartphone in a meeting is 54%. If we select 20 adult smartphone users, find the probability that exactly 15 of them use their smartphone in meetings or classes. Okay, so I'm going to come here, I'm going to go to formulas, more functions, statistical, and I'm going to go here to binomial distribution. Now, too many screens here. Way too many screens. Okay, so 15 out of 20. Okay, so I have 15, 20 trials, 0.54 was my thing. Now, I want false. If you look down here, the probability mass function, that means just 15, is false. Cumulative means adds up to 15. This is, we want just 15, so we're going to use false. So then this is 0.0309. This is ours. Now, any one value is always relatively small because we, in general, getting exactly 15 is always unlikely because we could get, 16, 12, you're going to get a lot. It's more beneficial to look at a group. What is the probability that we get 15 or more, 15 or less? So most problems are actually going to look at it that way. So let's see how that works. So the first one is exactly, it can be useful sometimes, but for the most part, not super, because any one value, for instance, I poll 100 baby girls, and I want to know how many weigh X pounds or something like that. Chances of getting an exact weight, I can get around, but, I'm better with a range. It makes more sense. Okay, so this next one, 10 users are randomly selected. Find the probability that at least 8 of them use smart. So this means that 8, 9, or 10, right? At least 8. So that means 8, 9, or 10. So what I'm actually going to do here is this does down. So when you look at this, okay, so I'm going to put in 8, but I'm going to come back. Oh, I don't know what I clicked on. Not that. Right here. I don't want the beta. Okay, so number of trials is 10. Okay, and this is 0.54. Now here we're going to use true. What this does though is this gives us everything up to a value. So this counts up from the bottom. So this would be counting, if I put in 8 right now, this would be counting 0, 1, 2, 3, 4, all the way through 8. I don't want that. I want 8 and up. So to figure that out, and this is, I'm going to write this out actually. So I want to know the probability more or equal to 8, right? Well, this is the opposite of 1 minus the probability of 7 or less, okay? Because I want 8, 9, or 10, and these all have to be discrete variables, okay? That means I want to include 8, so I want to take out 7 and down, which is what it's doing. So I'm going to actually figure here 7. Okay. This value then is 7 and down. This is what I want to take away. So C2, C1 right here. So this is my value, 0.0889. This is actually the value I want because this was 7 and down. I took it away, and then this leaves me right here, 8 and up. Okay, so just a heads up that when you look at these values in here, they're giving you down up to that point. So they were giving us up to 7, but I wanted up, so I had to subtract. Okay, now this next one is fewer than 3. So that means 0, 1, or 2. So I want the bottom end. So I'm not going to have to subtract from 1, right? Because I want the right end. So I'm going to go here. Now, I don't want 3 though. Read this, okay? This says fewer than 3. which means I can't include 3. So when I go to put this in, I'm actually going to put in 2. This was 12, I think. And then true. Okay? Yep, 12. So it's really important to read what they ask for and think about what numbers you want. And remember, this is discrete, so often you're not going to be putting in the number that you actually wanted. So for instance, I wanted 3 or fewer, but I'm actually putting in 2 because that's where the top one. I want to include 2. This is going to include 2. But I don't want to include 3 because that's not fewer than 3. Then over here, because I wanted 8 and above, which is this one down here, I then had to take away 7 and down. So just kind of some things to watch as you're doing this. Now you could, of course, do this by adding these up. Like this would have been, I could have figured out 0, 1, and 2, the exact values, like I did over here, okay? And then I could have added them up. But obviously, since we have one function that does it for us, why would we want to do it that way?